AP Chemistry, Unit 2.3, Structure of Ionic Solids. So ionic compounds involve ionic bonds. Those are going to be electrostatic attractions between a cation, which is going to be positively charged, and an anion, which is going to be negatively charged. For ionic compounds, when we're talking about conducting electricity, in order to actually be able to conduct electricity, a substance must have charged particles, and those particles must be free to move. So if we were to look at these two instances here where I have a very regular pattern versus more space involved, my solid, which is represented on my left-hand side here, those molecules cannot move freely, and so solids do not conduct electricity. However, a molten version of an ionic compound, where we are in a liquid state, I am going to be able to conduct electricity because I have space between my molecules where I can actually go ahead and move, which is required for the ability to conduct electricity. When you are drawing ionic particulate diagrams, you need to be careful about the relative sizes of your atoms as well as the charges represented and where those are. So below we're going to look at a representation of a portion of a lithium chlorine chloride crystal. A student wants to draw the structure for potassium chloride, and you need to go ahead and describe what the differences should be between the lithium chloride and the potassium chloride representation. So for the lithium chloride representation, again, we are looking for our cations to not touch other cations, anions to not touch other anions, and to have a relative size differential between my lithium and my chlorine. And if I were to be drawing the potassium chloride instead, I would look at the relative size differential between my lithium and my potassium. I'm going to see that my potassium is going to be larger than my lithium. And so for my differential between these two molecule diagrams, I would need to make my potassium ions larger. So my positive cation circles, they need to be larger. Now we're going to look at an example here. So the question states, what's wrong with the student's drawing below? So here we have a lithium and bromide diagram here. We can see that my cations are touching and my anions are as well. And then my relative size differential, lithium is a very small atom versus bromine, which is going to be substantially larger. So also the size between these two are exactly the opposite of how they should be. So the two errors that again I see are going to be that the lithium should be smaller than the bromine, and that they should be alternating positions so that my cations don't touch cations and my anions don't touch anions.